Good morning, everyone, and welcome to the trans4num Inspire Hackathon 2024 final event. It is a pleasure to see so many of you here as we celebrate the culmination of this common journey. My name is Markéta Kollerová. I'm from Plan4All, the organization leading the hackathon, and I will be your host today. As the official title suggests, this hackathon is part of the broader trans4num project, which focuses on developing and testing innovative nature-based solutions that help transforming the current agricultural systems into more sustainable ones with better nutrient management. This hackathon has been part of this common work for the past several months. It began with a call for challenges to identify key areas of innovation that are aligned with the objectives of the trans4num project. Once the challenges were defined, we issued a call for participants, bringing together talented minds from diverse backgrounds. The hackathon then officially began with a kickoff meeting. Then the mentors and participants formed their teams and started their collaborative work. Over the past weeks, these teams have worked diligently, brainstorming, developing ideas, and creating their final reports, presentations, and videos to showcase their solutions. All of these efforts have brought us here today to the final event, where we will witness their solutions, celebrate their work, and select, of course, the winners who have demonstrated exceptional creativity, feasibility, and impact. Before we officially start with the jury introduction and the team's pitches, I would like to extend my biggest thank you to all of you for joining us today. The mentors, jury members, and of course, the participants who have dedicated their time and effort to this hackathon. Today's event is an opportunity to present the results of your hard work. Each team will have 5 minutes to pitch their solution, followed by questions from the jury. After all the presentations, the jury will deliberate and select the top 3 teams, bronze, silver, and gold. So let's begin first with the jury introduction. I'm happy to introduce our dedicated jury members who have joined us today. Each of them brings their experience in managing European projects, hackathon events, and similar initiatives. Beyond their expertise, it's mainly their insights and commitment that ensure the integrity and quality of the final results. So let me introduce to you Mrs. Tuula Löyti from Smart and Lean Company. Tuula, please, would you share just a couple of words about yourself?
Thank you, Markéta. So I'm coming from snowy Finland, 40 centimeters at the moment, so excellent ski weather. I'm an entrepreneur. SME entrepreneur. The company is working with operational excellence and business intelligence. I'm sort of, if 4 Horizon projects is a good result, I'm experienced in Horizon projects and also in hackathons. So I'm very pleased to be here today and let the best win today. Thank you.
Thank you, Tuula. So now I would like to move on to Ms. 𝐈𝐍𝐒𝐿 𝐾𝐫𝐬 from University of Hohenheim, which is actually the coordinator of the trans4num project. 𝐈𝐍𝐿, the floor is yours.
Thank you very much. I'm 𝐈𝐍𝐿 𝐾𝐫𝐬. Actually, I'm the project manager of trans4num as a part of the coordination team. Here is Hohenheim University. My background is in food technology and agronomy, especially in cropping systems, and I get to know a lot of information in the context of trans4num regarding nature-based solutions, and I'm very happy and honored to be part of the hackathon. Thank you.
Okay, thank you, 𝐈𝐍𝐿. Now I would like to give floor to Mr. Martin Tuchyňa, who is actually an expert in GeoICT. So Martin, would you like to tell us something about yourself?
Good morning, everybody, and really many thanks for being able to share this event with you. As already Markétka said, I'm coming from public sector, located here in center of Slovakia in Banská Bystrica, and I'm really highly motivated with the input prepared for this event. As said, I'm responsible, or I'm supposed to be responsible to manage the support for environmental systems here in Slovakia, but have to say that I'm really looking forward to learn from all your projects and presentations, because what we are really trying to do is to actually make sure that any public sector environmental data, including the geospatial, are used in application domains. So I really look forward for your inspirations and to getting a more, let's say, experience after all these projects. Many thanks.
Thank you, Martin. Thank you for your introduction. And last but not least, member of our jury is Mr. Radovan Hilbert from also Slovakian company called YMS. So Radovan, the floor is yours now.
Good morning, everybody. My name is Radovan Hilbert. I'm representing the Slovak YMS company, as was said. It's a software house mainly dealing with the enterprise GIS system and remote sensing and decision support systems. My background is ecology. Also, I'm dealing with the natural disasters. So really looking forward. And I have to say that I'm already impressed by the presentation and videos I saw before this event. So I'm looking forward for the presentation, your presentations, and good luck to everybody.
Okay, thank you, Radovan. So I think now it's time to turn to the teams and to the actual work they have done. I will ask each team to briefly introduce themselves, their challenge that they were working on, and what kind of results their work has brought. After their pitch, the jury can ask questions to the mentors to maybe gain more insights into their achievements. So now I would like to officially start the pitches, and I'm asking the mentors of the first challenge, Katalin Miholicsné Orbán and Zoltán Füzfa, to introduce their challenge number 1, called Development of Spectacular Experimental Demonstration Tools and Content to Establish and Spread the Use of NBS.
So our aim was to make a content, a special educational content for our NBS help tool. And this is our team, so Katalin and me. And this idea to make this NBS help tools is to make more clear for the farmers and for the students and any interested people about the topic of NBS. What is nature-based solution in agriculture? Why it is needed? Why it is so important nowadays? And so previously we developed the idea of 8 different tools. You can see the plans on these. And finally, we invited a group of pupils, secondary age children, 16, 17 years old ones, with a lot of enthusiasm, and to do with them the whole content. So this is already the content development, and let's follow. It's changing?
Yes.
Okay, so it is running. So the challenge begins. We made different items, actually 7 items, clear for the hackathon. And I'd like to introduce these. The first was the idea, how to make it clear. And the second is the participants, what I introduced already, these students and the mentors. And the location, it is our center in the Dunasziget. This is a field experience center. And the communication tasks, what we are going to do together. And this is about the topic, the tools. The 6th. The 7th is the demonstration, because we had prepared the children ready for this, because they are just ordinary secondary school, no any special education for agriculture. So they had to get some knowledge on it. And then the university we invited, because they have a lot of knowledge and they can share in very good way. So we did experiences with them. and these were very useful. And the real hackathon, when it begins, it had 10 different chapters. First was how to get familiar with the tools, and the second, the participants get more information on their own topics. So let's say 8 topics we had, 8 tools, and 8 groups was formed. So each tool has got 2, 3, maximum 4 pupils working on in 3 days. And then was the next is the brainstorming discussions. It was the most time. And then they started to work with it. They started to fill it, for example, in this case with soil and with animals, with parts. And when they filled it, then they had to work further. They had to plant the different seeds, and they have to water it. And even with the composting, they had to work. They had to find worms and feed them. And here is the soil erosion. They had to fill everything with correct material. And also they had to work a lot on the creating visual and the text contents. And this was a very difficult part, but it was the most adventurous things, because they had to find the right words, the right questions that they asked for the visitors, and the right answers which could come out from the tool by using them. So it was a real good work, even for us. And finally, we made presentations. The third day, each group get 15 minutes to introduce their work and their results. And this was a real fun. So actually, what we are doing now, we did 1 month ago with them, and it was a really good experience. And they were really very enthusiastic and looking each other very silent and very open-minded. So here I'm just showing their presentations. This is the second group, the third group, fourth. This is the wind erosion, which was really much better made than we could imagine before. It was really working well. This is the soil erosion. We did 2 different soils, what you can see, and watering, and on the slope starts the erosion. And it's a huge difference if it has cover crops or it is without. And it was really working well and was very clear, the results. The 6th group and the 7th group with the composting process. And the 8th group is about how the soil is made by nature and how the soil organisms are helping us. So the final results through these 3 days was the tools have educational content. I will show you later. This project method was experienced, this 3-day, how it's developed, how it's built up. It was really a very good experience. And we could get an authentic learning, how the real world get into the classroom. So it's a very new kind of teaching method that we have tested, and it's really effective. We find it out. So these children have really deep knowledge from the topic. And also they could use their creative skills. So the creative design was made and the implementation was completed. And both they and we were very enthusiastic, and we learned a lot of things. So the final content which was made, the results on the hackathon. So I'd like to show you. It is in Hungarian, sorry, but you can see it's all of them is different, and in different designs, different tasks, different idea behind, but these contents will be used under the tools in a desk, in small shelves, and in these way, the audience, the farmers, the visitors will go through on the same process how these pupils went through. So maybe longer than 5 minutes, but these were the results. And yes, and the next steps still we have. So you can see here these drawers with the contents, and this still has to be worked on it. So we have work with my colleague, and the last tool, which will be the leading to the center of the let's say experiment, it has to be finalized, the mock-up. Yes. So thank you for your attention, and this was a part of the group. So the center is trans4num and NBS. Thank you.
Thank you, Zoli. It was an amazing presentation of the work you have done with your students. And I would like to ask our jury if you have one question for the team. I see that Martin has his hands up. So Martin, please.
Yeah, many thanks for really inspiring presentation, especially with the connection to the direct young people. I was wondering, what do you think was the most important motivation to attract the young people for your challenge? Because we know that it's very difficult these days to really get teenagers really on the topics which might be complex, but it's very important to get them on the board.
Yes, this was quite easy because I'm geography teacher, and for class 10, this grade, the topic is the living Earth, and
Okay.
they know very well that so many troubles are around us, and they are very, very much interested how they can help on this, and they have the real wish to do something better, and how to do better through educate people. And they are already brave enough to see that they can have effect for younger people. And through these MBS tools, they felt that they can help others to understand the problems, and not only the problems, but how to do something better in agriculture. So we never said this is the problem, but we always said there are solutions, what we have to do, but why we have to do. And this was answered.
Many thanks.
Thank you. Faro, you also have a question?
Yeah, thanks a lot for the nice presentation, and as Martin said, inspiring work with the young children or teenagers, as you mentioned. I'm very impressed. I had one question. I mean, this is a really good idea, this authentic learning. I was wondering, do you have any plan, or can you see a way of just extending your audience beside your center? I mean, it's great to have that center, but it's not reachable for a bigger audience. Do you foresee something in future that this result becomes available for a bigger audience target? Or
yes, I think the hackathon will follow. So next, I think there will be next second hackathon. So I think next time we would like to open this topic for greater audience, and our tools are very specific and very specially made, but there is an option to make them much simpler and much more useful for the whole Earth. So it could be made in any classroom, from simple materials. And this will be the topic of the second hackathon: how to make simpler and very easy made tools for great audience.
Thank you.
Thank you. So one last question from Tula.
Actually, not question, because I already got at least part of the answer. But I continue anyways. STEM subject is something very important. You know the term STEM, right? Science, technology, environment, mathematics, it's STEM.
Okay.
And it's very near to my heart, has been many years. In my city, in Lahti, there is a STEM center. So this center helps primary and secondary schools to put focus on STEM themes and topics. And maybe this kind of a idea of the center could be your big vision in the future, so that you can bring in your tools and ideas. That was something I wanted to share with you. Another thing is that experimental approach at school is a great idea. It's a great tool to stimulate youngsters' mindset. So I'm very happy to hear that you are experimenting. We need that kind of knowledge and attitude. And the third thing what I want to share with you is that I value very much that you build people, not application, not anything bad with applications, but you build people to make something good. Thank you. No questions, just comments.
Thank you.
Thank you,
Thank you very
Tula,
much.
for this beautiful remarks. Okay, so I think it's high time we move to the challenge number 2. And here we have Dr. Naya Praza and her challenge, 𝐈𝐍𝐒, a sustainable food for soil. So Naya, the floor is yours.
Hello everyone, my name is Naya Praza and I'm the founder of 𝐸𝐻𝐻, which is Sustainable Food for Soil, which is the product of 𝐈𝐍𝐻𝐻 SMC Private Limited. So everyone present here is very well aware of the common problem we are facing today. And chemical fertilizer we are using our own land or with our own hand. Let me introduce a flip picture what kind of poison we are providing and feeding our land with our own hands, that is chemical fertilizers. And 27% greenhouse gas emissions only comes from the excessive use of chemical fertilizer. This is not only that one, it's also our GDP's losses, which is escalating by 3.5% by 2050. And average global yield loses by 6 to 15% as well. And this is the only data for the UK. And now think about as a whole, like how the world is suffer from this chemical fertilizer by providing a food as well. So I have a amazing solution that is 𝐈𝐻𝐻. 𝐸𝐻𝐻 is basically a carbon dioxide biocapture solution, sustainable solution, which is manufactured from a very innovative solution from the microalgae extractions and the waste nutrients and recycling of the carbon dioxide capturing, which is made up of natural based solution, that is the natural microalgae, and which is reducing the cost by 53.3% and the crop production increased by 12% every second year of application, which is turned into circular economy, increase the food production and also climate change. And this also, which we have followed the policy of the EU soil strategy, which is protecting and restoring degraded soil, at least 40% reduction in chemical fertilizer use by 2030. So this is the unique selling propositions validated by our customers. The 165 liter which we used on the acre, which sequestered the minus 2.7 kiloton per hectare per year of carbon dioxide, which is calculated by IFT software. And farmers' yield crop increased by 12% and improved soil fertility as well. This is the data which we achieved from the work which we have done with the USAID project. And our 60 to 75% reduction in soil salinity, basically with 12 months of dose. This is the one of the study which we have done in one of the province in Tandokesar with the help of UNDP. And amazingly, this all the sustainable development goals we all are follow with our pagicum of focus with this, because PAN addresses all the carbon sustainable development goals, especially 1, 12, and 30. So as we know, FAO, World Food Organization, said like in all the world, many of the people just living for their agriculture for their livelihood. But not only this, the farmers lives in rural areas, and that makes most of in the world, like 55%. So our market is like from total addressable market to our SOM, like how much farmers we are going to capture from this, and that our farmers market size is 0.5 million, that is 94 million market size, and PAN is only captured 32.5 million of that cost of the market as well. And the PAN cost is very, cost effective as compared to existing solutions, that is 2 pounds per liter per hectare of the soil. So if we talk about like what is the competitive advantage which our product and the other product which are existing in the market, if we just talk about one of the like just the cost, the cost is reduced by half as compared to urea. And also if we see the composition is very safe, which is a nature base, and as compared to the other that is more excessive chemical fertilizers. And in terms of carbon dioxide sequestration, it is positively sequester the carbon dioxide. It's not negative emitter. In other words, salinity is reduced, but by the chemical fertilizer utilization is increasing over time. And the crop yield, which is increased continuously after second year of application, which is also fertile the soil with the passage of time. But as compared to this, that is 12 to 50% decrease every 3 years of the degraded soil. So this is the 𝐖𝐍𝐬 dynamic hackathon team. I think I'm very blessed to connect with those people because they are from very diverse team, which I have collected from like China, from South Asia, and from Africa as well. Because I believe my solution is not for the UK, it's not for the Pakistan. Now it's for all the world, because all people based on feeding food as well, and all the problems right now is not facing only one country, all are facing globally now. And these teams are for a month, they are indulged with focus group discussions. We are indulging with different kind of farmers discussions as well. And I have collected a very good data, which might be publishable as well through our survey in different countries as well, and also focus group discussions as well. What we get, because they all are from the very good background regarding the climate change and also agriculture side. And also Antony and Obot, I think they gave a very good data as well, trans4num and 𝐖𝐢𝐧𝐧 as well. So transform result is just like we can say we don't have survey, focus group, meetings, landing page as well, which is our official landing page now. And we believe like, because I have surprised from the finding as well, because farmer wants a solution, but the thing is that they do not aware of that, what kind of poison they're actually feeding their land, because obviously they are not technically related with the background of what kind of things they are providing their land. And also we have like in focus group discussions, we come to conclude that it's not a problem for only one country, it's a problem I think in globally now. And if you talk about China, if you talk about trans4num country, and also other African countries, I think they are suffer a lot, but no one is talking about like what kind of I think damage they suffer now, and they want solution right now. So this is the market discovery, which is potential here. It's like bridge from I'm working here in the UK with different kind of customers, and they all are 𝐖𝐢𝐧𝐧 Council and also First Manager and the bridge farm. Right now we are working with them with our solution. And this is my team. We are a mix of team like from 5 years now, and we are working on our solutions, and we want to scale up right now and globally as well. And they all are working in their areas very well because they all are, I believe they have dynamic team. They are all skills and they have a background which can help me to scale up my business globally now. Thank you.
Okay, thank you very much, Naya, for your presentation on this very interesting topic. And now I would like to give floor to our jury for their questions. I don't see any hands up, but I'm sure they... Oh yeah, Martin, let's start. Thank you.
Yeah, many thanks also for this interesting product presentation. I was wondering, based on your experience so far, seeing that you already are investing a lot of effort and energy to this initiative, what do you consider as a successful market uptake for the product from what you experienced so far?
So Martin, when I started work from Pakistan, basically, there is basically farmers don't have a knowledge, even in the market size, they don't know like really is this kind of product which they can replace, or even they can minimize the chemical fertilizers. When
I see.
I'm here based in the UK, believe me, in the market, they really need a solution. But the thing is that when I came to know through the farmers in the Norwich Research Park, uh, I've been just discussion with them. They said like in a market, farmers really need a solution, which they they reduce the pocket, because they paid a lot of money on just purchasing a chemical fertilizers. So they really want a solution. But thing is that they said we don't know what kind of if anyone provides us a solution, what kind of solution they're providing, and what kind of after effect on their lands, on their soil. So thing is that the only one thing, if we can just capture the market, we need to make a trial. We need to make a trial on the lands, and if they can see the results very clearly, and also with us scientific, because we have done a lot of experiment as well, chemical, physical, and also just check the soil degradation and soil fertility as well, how things change, we know with the scientific methodology, experiments, etc. So I think this is one of the parameter we can provide to them to see that how things change before and after use of that product. So I believe, I think seeing is belief. So I think we can just minimize this easily, but I think it's about awareness. Making awareness among the farmers is very necessary. And also when I come to know about those people from through Hackathon, and I think they give me a very good information regarding their country as well. And from this point, I really, because in one of the member, they want to, they really want to know about the farmers, so they want to connect with me and they want to work with me as well. So I think this collaboration is, I think, ongoing, and I believe I can easily capture, but I really need to just scale up my business right now. I really need to scale up my product as well, because obviously to providing for trial of my product, I need to scale up. So I think a huge market is here, huge market, and that is uncaptured, unfortunately.
Okay, thank you, Naya. Faro, your question?
Yeah, thank you very much for introducing your idea and the presentation. Actually, I had some maybe a little bit more technical questions. I was wondering for which kind of crops you have tested your products, and when you mentioned you had in 2 years field experiment increase in the final harvest, or did you consider the environmental condition, and do you know that it was the effect of the fertilizer, or how much of the effect was the fertilizer effect? And yeah, I mean, basically, I wanted to say that the challenge is globally, you're right, but I think sometimes a complex global challenge does not have maybe one recipe solution. And I wanted to know for which crops did you use it, and how do you foresee in different regions, or for regional solutions it's effective?
Oh, okay. Yeah, that's a very good question. The thing is that I have tested on different crops. It's not about only like a rice or wheat. No, because I have different vegetables as well. So that is proven for all the vegetables and all the crops as well. Because with the I have been working with UNDP and also USAID on 2 different crops for just open condition. It's not about a greenhouse. I've been working on wheat and rice basically, because That's a staple food, and it's need I think they really need a huge in quantity in everywhere. So they said like you need to make a solution on particularly in those crops initially, and then after that we can do that. And that the work which I have done in Pakistan, that was published as well by USAID and UNDP. And the thing is that for the region, because 3 years before I have been working in Pakistan, but now I'm here. Now my work I've already started in the UK. So in UK and Pakistan, the temperature and weather, there is a very, there's a very much difference. So I believe my product is working in any region. But the thing is that, like, if you talk about, if you can say it's in like Antarctica, I'm not saying like, oh, I just claim it. It's been working in Antarctica, not like this. But I can say because I've been testing my product in 2 regions, so I can believe it can be work easily in anywhere. And also I need to mention, because I've been working in nature-based solution, Germany right now, and also US is the very biggest, I think it's a fish market for microalgae extracted and so the thing is that I've been extracted my species from naturally and from my country, and I brought here through a proper channel into the UK. So I believe it's genetically free, and there's no anything in that. We just, because I've been working since 3 to 4 years on my product right now. So I'm very confident about my product, because it's not about just making a trial at the lab scale, because it's making a trial in very open scale as well, in open field as well. And when you talk about like it's really your product, or it's like an environment was working. No, basically when we applied that product on that open land, basically we got the results through the soil analysis, because we just divided 2 things. There's a one patch without the product, and the one patch is with the chemical fertilizer, and one patch with our product. So there is, there's a study which we have done with the comparison and see the, soil analysis stuff. And also we sent some samples to the UK as well for further analysis. So there is a proven, and also we have done testing a lot as well. Yeah.
Thanks a lot. If I may just give a comment, I would just consider also the effect of the product on the biodiversity, especially on the microorganisms of the soil. And I think longer experiments are needed to just
exactly.
have this in mind. Yeah.
Right now, because I've talked with marketer as well, because I've not, openly just discussing everything. Right now, in Manchester University, we are focusing on microbial diversity. This is one of the gap we have found right now. So we are working on that one as well. Yeah.
Thank you.
Okay, thank you. Are there any other questions on Naya? Yes, Tula, please.
Did I saw correctly that this stuff product can be used also for composting, bio-waste composting?
So, Chula, the thing is that composting is different thing. Composting, people usually make like, vegetables, whatever the waste in the kitchen waste, they just make in a soil, and then you just cover it, and they just make a compost in anywhere. No, it's not a compost. This is a different thing from the compost. This is a totally different thing.
Okay,
So
okay.
usually, yeah.
The reason why I asked, I thought that I saw some mention in the slide set, but I have understood that microalgae can be used to, boost the composting process.
Oh, okay.
And composting
I got you.
and circular economy, there is a hype, some kind of a hype there. So maybe you can consider also, if your product is usable for that purpose, to go to that direction.
Okay.
Just this one. Okay, thank you.
Thank you.
Okay, thank you very much for all the questions. And I think we can move on to the next challenge, is the challenge number 3. Herewith we are starting with the technical ones. And I would give floor to Mr. Peter Šimánek from the Czech Technical University in Prague, who will introduce the AI-based cloud-free crop monitoring challenge. So Peter, the floor is yours.
Hi, I hope you can hear me and see my slides.
Yes, perfectly.
Yeah, thank you. So I will probably disappoint Tula because we have a tool or method, but I would like to connect to the very interesting previous 𝐖𝐍𝐬𝐬𝐻 thing that we can possibly try to understand the effects of these fertilizers using satellite data, satellite images, and this is what we do in our topic. Our challenge is that in agriculture and precision agriculture, we need a lot of frequent and high quality satellite data. The reason is that using this satellite data, we can very well monitor deep information about or valuable information about the crops and the soil and so on. But there is a problem that very often there is cloud cover that hides this information, and especially at times when it's the most important, like during harvest or during March, April, and then this information couldn't be used. And it's very difficult to track some vegetation indexes like NDVI, and it's difficult to decide quickly what to do, how to intervene in the farm. So we decided to create AI tool which tries to remove the clouds from the satellite images and try to estimate the vegetation indexes that are hidden by the clouds. We wanted also to find out if we can forecast the crop dynamics like under varying conditions. We used two kinds of satellite data. It's Sentinel-2, that's like the main source of data, which gives us 12 spectral bands. You can see that these are just photos from space. Then there's Sentinel-1 data, which gives us radar images, which are always there regardless of cloud cover. So this is helpful. And we merge these with some soil type maps, some weather-related data, which are also based on satellite products, but different geostationary satellites. We used the data from Czech Republic from 2 years, and we use this 10-meter resolution. Here you can see the architecture of the AI model. This model is called Uncertain-TS. This model is quite difficult to understand, so I won't go into many details. But what we do is that we ingest all the satellite images and soil data and weather data into this large neural network, and we don't only use like last one image, but last 5 images, so we can see some development. We are also currently exploring some advanced AI models like diffusion models. So if you ever used your AI to generate image, or if you saw AI generated images, they are almost always based on some version of diffusion models. And this seems to work well also for this satellite imagery. We wanted to the model was trained to minimize losses, which are mean square error or mean absolute error, which we really wanted to say we want to have as good as reconstruction of the Sentinel-2 images as possible, or the vegetation indexes like in DVI. Yeah, here you could hopefully see the table, which is here. There are some metrics. The lower the metrics, the lower the number, the better. It means better reconstruction of the cloudy image. And we can see that, and we did many more experiments, and we know that currently this approach is like state of the art, the best thing that could be done, or that was done and was presented elsewhere. We found out that using Sentinel-1 together with the Sentinel-2 data helped us a lot. And we found out that also like adding soil and weather data didn't help us much. We are still trying to understand why and how to change it so it helps us with this reconstruction. And currently we are also working with the Sentinel-3 data, which are also image data, so they have trouble with clouds as well, but we have them much more often, so like twice a day. So we know right now that adding this Sentinel-3 data helps us a little bit. They decrease the error by another 3%, which is nice because it's quite a cheap way to improve the result. Here we can see that what is the prediction. Here you can see like the cloudless NDVI, cloudless Sentinel-2 image, and here is the real cloudy image from Sentinel. We are also trying to. There are some limitations because of the very high resolution of the Sentinel data. It is a bit expensive to deploy this all over the world, and as it was trained only on Czech Republic, we are not sure if it would work correctly on the whole globe. But we have experiments from let's say Colombia and Chile, and it seems that it works quite well, which is good thing. We are also working on the diffusion-based model to improve the results further. So the conclusion, we are able to develop the AI method that use radar and optical satellites to generate the cloud-free images, and we know that we can do even better next time or in the next steps. So thank you for your time and attention.
Okay, thank you, Peter, for our presentation. And now it's time for our jury to ask the questions. Martin, please.
Yeah, also many thanks, Peter, from my side for this clear and nice presentation. I would have said a few, hopefully short questions. So let's start. What do you think is the position of your approach towards the already established solutions on the market? Whether you already done some sort of comparison, what is available on the market and what is, let's say, so added value of your approach? The second question would go towards these predictions you mentioned. They were made for how many months, years in advance? And if the third question would go to the direction, what do you think is the main potential market where this kind of solution might be really taken and promising based on your experience? Thanks a lot.
Yes, thank you for your questions. We compared our results to other AI-based solutions which are in available research literature. So I'm not sure about what's on the market right now, because usually these things, when it's on the market, it's already 2, 3, 4, 5 years old. So we wanted to compare to the latest results, and we did this comparison, and we know that we are currently better. So hopefully this will be true also for the other tools. Regarding the prediction, we definitely can't predict years and not even months, but we can we try to predict next 3 or 4 Sentinel-2 slides images, which is something like 6 to 9 days. This can be used also as a basis for experiments, like the farmer can do experiment that if he does nothing, he expects some kind of result based on our based on our method, but he will do the experiment, and he can see like the difference between our prediction and the real state of the field that happened after his intervent, if it makes sense.
Sure.
Yeah, and the last question was, sorry,
the last one was towards the application domains. Where do you think these, let's say, approaches and knowledge might really be sort of game changer?
Yeah, so definitely we hope that agriculture is the domain. We know from Czech Republic that there are many farmers already working with satellite data on daily basis. So this would be another tool for them. But besides agriculture, there is still open field of application, let's say in catastrophe monitoring and so on. Last week there was this typhoon that destroyed a French island close to Madagascar, and it was really difficult to say anything about the island because the satellite data were cloudy all the time. But we could probably, using mixture of Sentinel-1 and Sentinel-2 and 3, give them information like what's changed, how does it look like now, even without a clear image from Sentinel-2.
Great, thanks a lot.
Thank you. Thank you, Peter. I saw Tula's hand also.
Yes. Last year, no, it was this year, I bought a case study from Sierra Leone, from wrong guy, and I asked to make an application or a study how satellite data can be used to identify illegal dump sites in Sierra Leone. And the accuracy was, I'm reading the study, 62%. So it was not perfect. So I'm very happy for this study of your team, because I imagine that also in Africa, eventually they will get better results and more accuracy, and we can get rid of illegal dump sites. So that's one domain more.
Yep.
For your information, not in Europe perhaps anymore, but in Africa there is a lot of opportunities.
It is actually still important also in Europe, let's say in Czech Republic. Sometimes people move a lot of lot of garbage, like from construction and so on, to some field, like without telling anyone, and it's then very, very expensive to get rid of it, and even to find out that this happened. So this can again help removing this problem faster.
Indeed. So when you are going to that direction, waste management direction, tell me. I have
Okay.
something to do with that. Thank you.
Okay.
Okay, thank you, Tula. Are there any other questions for Peter?
Yes, if I may, just one remark. Also, this approach is great for the monitoring of the forest, because we did some studies in hilly areas, and we had a big problems with the morning fog. So this also could help a lot. And the question is, if the results or the reconstruction of the images are mostly based on the radar data or mostly based on the image analysis of the sentinel object?
It is both. Without the radar, it doesn't work that well. But you know, from the image, you can see that almost always the cloud coverage is not like complete. So there are some pixels that you could see something green. So we are using this information together with the radar information, and also it learns some standard dynamics. Let's say that every march it should behave like this. The vegetation should behave in a certain way, so it helps.
Thank you.
Thank you. Foro?
Yeah, thanks a lot for presenting your idea and the solution. I had a follow-up because it seems like the application is in different domains, as everybody now is mentioning. So do you have any plan, considering you said it may be expensive? I did not understand. The expense comes in development, or the expense comes for the end users? And how do you gonna address the cost-effective solution for end users?
It would be very expensive to do this on the whole globe at the same time. But if we do it on demand, like let's say we want to check some forest every day, then it's not expensive. It's just a bit more expensive to make it like completely global. But if it's on demand, then it's no problem.
Thanks.
Okay, thank you. So I think now we can move on to the challenge number 4, to Mr. Miroslav Čepek, also from the Czech Technical University, whose challenge is called High Precision Meteorological Forecasting Challenge for Optimizing Agriculture and Beyond. So Mirek, the floor is yours.
Hello, good morning. So as stated, we were looking on how to improve localized weather prediction through machine learning. You know, we are looking at agriculture, where you can really benefit, or we hope you can really benefit by knowing exactly what the weather will be on your field or on your farm. For that purpose, it's really hard to use global numerical models, because they are too coarse. Like their resolution is typically in tens of kilometers, so it's not taking into account your local specifics. And maybe even though the global forecast saying it won't be raining and there will be no wind on your particular field, it may not be true, because you're on top of a hill where there is a wind all the time and rains half of the time. So we are looking into ways how to incorporate local knowledge into the global forecast. So our approach is to basically combine global forecast with local information, specifically from a commercial weather station that you can actually buy and put into your field and like start collecting the data. In the end, our machine learning approach or AI approach basically corrects the weather, the global forecast for local specifics by using the measured data from the weather station. This picture tries to show the architecture of the system. So we take the global forecast. In this case, it was GFS, and we combine this forecast with the local weather station data and put this into artificial intelligence, and we hope we will get a forecast for into the future, like 24 hours, 12 hours, 2 days, etc. We are also this actually works reasonably well. We were also thinking about how to improve the accuracy, so we incorporated another step which takes into account Era 5 land, which is basically reanalysis, meaning it's available only for the past. So it's a numerical model which has weather based on the forecast and the actual measurement in the past, and it's much more detailed. So we were trying to combine the global forecast GFS and trying to downscale it using artificial intelligence to Era 5 level, and put this estimation of Era 5 into the forecast and basically repeat the exercise. So combine the Era 5 estimation with local weather station and run it through AI and get the forecast. Here are the examples of how the estimation of Era 5 worked. So at the very top, you have like a GFS forecast visualized on some area over Czech Republic, if I remember correctly. Then we have the forecast for Era 5, that's the middle row, and the ground truth is, or the Era 5 reanalysis as it was calculated, is at the bottom row. And if you compare the 3 rows, you can hopefully see our middle row prediction is slightly better than what the numerical model is saying. Here we have the results. So it's those bars down on the picture shows the accuracy of 3 most important weather variables. So the temperature, dew point, and wind speed. So it's the easiest to. So our performance is like 20% better than what the numerical model is saying. And if we put in the Era 5 estimation, so make it a little bit more complicated for ourselves, we can get another 20% accuracy. So in terms of temperature, the average error on numerical model, the GFS, is like something like 3.1 degrees. If we put in the local information from the weather station, it's like 2.2 degrees roughly. And if we put in the estimated Era 5, it's something like 1.3 degrees. So the AI can improve the accuracy of the forecast, and you as a farmer can better understand what to do, how to care for your field. If there's a risk of frost, for example, or maybe it will be raining too much, so there's no reason you should apply fertilizer, because it will be washed away in 2 hours because it will be raining, or you should not collect your crop today because it will during the harvest it will be raining. So it's better to wait another day, and then it will be all sunny and no troubles with rain. We actually implemented like a system. So these are 2 examples from 2 weather stations. It's two weather stations, like one above and one below. They both shows the temperature above ground and underground, and you can the left 2/3 are basically weather, historical weather, and the dashed line on the right margin is the forecast, and you can compare, because it's on history. We also have the actual values as the weather station captured them, so you can compare how what we are predicting and how we are matching with the real data. You can actually incorporate like relatively easily any additional weather station. So there's a process how to define how to download the data from the weather station, and if you implement this bit, you can easily put it into the system, and you can start to benefit from your system. So far, it's just the forecast. So there would be a little bit more effort to alert farmer about like some conditions that are important for his decision making, like there's frost coming, or there's a high humidity situation, etc. And so basically that's it. So we had like 5 participants who are working on this, so we can enhance the forecast accuracy for farmer for his particular field, and help him to better decide to what to do to save his crops, or save his harvest, or help him to understand what's the best time to apply fertilizer, so we can actually reduce some waste and reduce the pollution of the environment with washed away fertilizer, and so on. So we want to add some more measurements into it. We want to understand if we can somehow approximate the weather station data with maybe topography, and or maybe understand or approximate the weather station from nearby weather stations, etc. And then obviously we need to scale up our operations and get it to customers and to real use. So that's it on my side.
Thank you very much, Mirek. So just because we are really running out of time, I will now, from now on, allow only one question from the jury. So Tula, Foro, Radovan, or Martin. Yes, Martin, please, your question.
Yeah, thanks a lot. Just flash one. Did you already manage to think what might be the product or products this solution could somehow support going towards more the market direction?
Yeah, we are thinking about it. The idea is really to have like a system where you will register your station. You will define how we can connect to it, and then you will ask for specific alerts based on what you are interested in. Maybe in the future we can you will just say I'm growing wheat on this field, so I'm interested in set of alerts for the wheat, and we will and either you can actively look at the forecast and see what's going on, or you will receive an alert on your mobile phone, like an SMS, for example, that will tell you there's something coming that you should be worried about.
Okay, so sort of service provided to the clients and customers. Thanks a lot.
Yeah, exactly.
Okay, thank you very much, Miroslav. And now let's move on to challenge number 5, which will be presented by Mr. Karel Charvát. And the challenge is called AI-enhanced geospatial analysis for rural development. So, Karel, the floor is yours.
I think that it is not easy to speak after previous presentation, because most of this work was done with the result which could be really very soon implemented on the market. What I will be presented is not a vision, it is some prototyping work about could be the future of European artificial intelligence for rural development, agriculture, and also for other areas. As it was a part of challenge 5, we work as mentor with Alexander Kovalenko, and we had the international team of the researcher people about the data, students preparing the data and preparing the test. I will start with some ideas introduction. Yes, there were very fast development of artificial intelligence in last 2 years when appeared ChatGPT and this other technology, and they start to generate new direction for future artificial intelligence. What I see as the big problem is that all the solutions are coming out from the Europe, and we don't have a really European solution, and it is making us very dependent on something what will happen abroad. And if something happened, anybody will all switch the artificial intelligence, or will serve us with information which will be not the best for us. We could be in the trouble. So we start with a great vision, and this is one from the first step of the great vision, how to build future European artificial intelligence working with geospatial data. Till now, we are, of course, using also the system out of the Europe, but our dream is that on the end, we will be able to build fully fully developed European system, which can help us. Why about geospatial? Yes, it is very interesting that till now is not so big focus on geospatial AI or this generic AI for geospatial, but on other side, the 80% of any information which are every day generated in the world has some geospatial aspect. Yes, you heard about weather forecast, you heard about you heard about satellite images and other, but every car, every agriculture machinery, all is now generating a huge amount of the information. If we will look on the classical, if we will look on the classical solution which is now used in these systems for for large language models, they are trained on a very huge amount of the data. But this amount of the data which was used for the training of this system is much smaller than is generated in the geospatial world, and our estimation is that in Europe is not such capacity of production of the electrical power that we will be able to train the system in such way how it is done, for example, for ChatGPT. So we start to thinking about some distributed system where we will use as a center some large language models which will be trained with could be less information, but we will also use the sets of different analysis, and what will be the core will be on the base of the user question to recognize which analysis will be the most relevant for your answers. Yes, we will have the catalog of analysis, and we will when will be sent the question of the user, this module will make the analysis of this question and will compare this with the application in the catalog, and will ask this distributed application, which will be on different places, to give me answer about your data for this area. This will help us to distribute the effort, but also not to have needed to train any information, but which will be able to use much less power than is necessary for such huge training. During the things, we developed two prototypes. 𝐬𝐸𝐬, you can see the 𝐬𝐸𝐬 on the screen. And it was some interfaces and querying the data from different areas. And second, which group developed this processing of the queries and searching in the catalog of different services and selecting the most relevant services for this answer for GeoChat. So this is what we succeed. Now the next goal is to merge both solutions into one solution, and our idea is that, of course, it will be more tested in other projects. And although we are now trying to invite other groups to cooperate with us, because this we see as really something very challenging, and that we will need some help. So here are our contacts, and I am ready for your questions.
Thank you, Karel. So now I give floor to our jury for one question, please. Yes, Martin?
Oh, sorry. Thanks a lot, Karel. Really, I already got some insights from work you've done in this direction a few weeks ago in INSPRE conference, and I was wondering, based on the results you achieved so far, what do you think when we shall expect the main switch towards this new technology approaches, especially in this domain of GeoICT, and particularly towards this direction of the event itself? Will it be in let's say questions of years, or it will be question of decades, based on what you've seen so far?
I hope that it is questions of could be years, yes, or I hope that some real prototyping. Not at first we had to start with using this existing large language models because this is the huge issue, but I think that the result or some work with this will be possible already during next year. The other things is to select and to focus on the developing of some European language models. There is number of the team. We are now looking for the partners who can cooperate. So with ChatGPT or with other model, we are able to work very soon. And I would like anybody who is interested to cooperate, invite on the end of January to Prague. We will organize 27 and 28 of January, we will organize Code Camp where we can continue with the development of not only this tool, but also with other tools. So we are now trying to invite a broader European community to work with us. And I hope that after this, and also with the training with more data, you saw that there will be only few data sets, but we need to mainly develop the way how to register new data and services in the catalog. And I hope that with this we will be able during the first half year to make some, could be not a final solution, but some good prototyping which will be possible to use in a broader scale.
Yeah, thanks. This ideation is very important, and I have to admit that maybe half a year I didn't expect that this GeoAI is really getting so fast on the seed in general. So it's good you are on the track, and looking forward for the upcoming results of your efforts.
Thanks.
Okay, thank you very much to both of you. And now let's move on to the next challenge. This will be the challenge number 7, regional nutrient balances for better decision towards nutrient circularity, and it will be presented by Hannah Frick from FIBEL. So Hannah, the floor is yours.
Hello, can you hear me?
Yes.
And you can also see my slides?
Yes, perfect.
Great, perfect. Thank you. So my name is Hannah Frick. I work at the Research Institute of Organic Farming in Switzerland. I focus mainly on projects in soil science and nutrient management, and I'm part of the trans4num consortium. So in this challenge, I worked towards developing a model to calculate regional nutrient balances for, as said, better decisions toward nutrient circularity. Currently in agriculture, nutrient flows are mostly rather linear, and especially on the landscape level, there's a lot of room for improvement to making nutrient systems more circular. Nature-based solutions are an interesting approach to achieving this. However, there's a need for better data, and especially for an overview for the local stakeholders on the current nutrient situation in order to help them to discuss, to collaborate, and to find better solutions on how to make nutrient flows more circular. So in this challenge, we aimed to collect data and develop a modeling approach for calculating such regional nutrient balances for the trans4num case study sites in Europe. I worked in this challenge with only one participant who is based in Burundi. So based on this background, we had to reframe the challenge a little bit because we had only limited number of people, and also the expertise was not there for working a lot on the European sites. So we decided to focus only on one example in Europe, which is the Limfjord region in Denmark. And then we expanded the challenge to also include an African perspective with the case study of the Burundi highlands. What we did during this challenge, we analyzed the current situation in both sites. So the Limfjord region in Denmark mainly suffers from too high nitrate loads and environmental problems due to nitrate leaching. While on the other hand, the Burundi highlands, they suffer from nutrient deficits, and the farmers there have the challenge of land degradation due to climate change and the long-term overuse of the soil without replacing the nutrients that have been taken up by the crops. We discussed on these two case studies. We also analyzed the stakeholder needs in these regions, and we tried to come up with some quantitative information. For the Burundi side, we did not have enough time. For the Danish case study side in the Limfjord region, we were provided with some data from our project partners at Aarhus University. And we managed to combine this data with a core model that was provided by colleagues here at 𝐈𝐍𝐒 that is able to calculate a regional nutrient balance based on administrative regions. However, our aim was to use the catchment scale. So we used the specific data provided by Aarhus University and customized their code to work with the new data. And we came as far that we could generate an output. However, we did not have the time to validate this data, and this is what is going to happen next after this hackathon. Thank you very much.
Thank you very much, Anna. So now it's time for one question from our jury. Okay, Tula?
If I don't understand anything about the challenge, this is the standard question. What is your exploitation plan?
So within trans4num, our aim is to develop a decision support that is supposed to be used with farmers to, and also other stakeholders in the case study sites, to help them figuring out better ways to close nutrient cycles, not just on their own farm, but really to foster dialogue between farmers and to make them collaborate and exchange nutrients, and maybe also with the further value chain to use these nutrients in a better way. And this regional nutrient balance for us is kind of the baseline for this decision support tool. And it's in our mind also a way to visualize scenarios, meaning that, for example, if we discuss a certain nature-based solution that could be implemented, that we could then visualize what would happen to the regional nutrient balance if this solution was implemented.
Okay, so farmers on the other side, and then regional authorities or decision makers on the other side.
Yes.
Right. Thank you.
Thank you. Martin, really quick question.
Yeah, just maybe the question from bigger perspective, based on your experience so far, what is the main, let's say, driver somehow influencing the domain of nutrient balances from, let's say, from the global perspective? Is it more driven by the market demand for the quality products, or it's more driven by the policy and legislative requirements based on your experience?
Well, it's a good question. I mean, farms are businesses. I have this European perspective where we in most cases face rather like a surplus of nutrients. So this is quite different to the situation that we face in Africa, for example.
Mm-hmm.
But like from my European perspective, we have a lot of regions in which we do have a surplus of nutrients. And this is, in my opinion, mostly because farms need to run economically. They need to maximize productivity, and this leads to an overuse of nutrients.
Perfect. Thanks a lot.
Okay, thank you very much. And now it's time for the very last presentation. It's the challenge number 8, led by Anke Möhring, and it's called Fundamentally Different Case Studies of Nature-Based Solutions. How can they be integrated into a common agent-based modeling approach? So Anke, the floor is yours.
Thank you. Hello, everybody. I hope you can hear me and see the presentation.
Yes.
Yeah?
Yes.
Yeah. Okay. So Challenge number 8 shows the results of the Sino-European collaboration to develop an agent-based model specification for nature-based solutions. I'm Anke Möhring, and I've been working at the Research Institute of Organic Agriculture, Fiebel in Switzerland. And my task as a mentor of challenge number 8 was to work together with our Danish and our Chinese colleagues in the trans4num project to develop a common modeling approach and a model specification that would serve as a starting point for the implementation of a core model in the NetLogo programming language. The focus of this challenge is on developing a model concept that can be used to investigate the adoption of nature-based solutions in different political, structural, and ecological settings. And the challenge is to develop a universally applicable core model that can be adapted for different case studies. Initially, we start with one case study site in Europe, which is Denmark. It is also the northern Jutland region or the Limfjord area that Hannah already introduced in her presentation. And the other case study site is the Inner Mongolia in China. But the model should be also useful for other nature-based for all nature-based solutions in trans4num if it is required, and potentially it could also be used for other beyond the trans4num project, also for other projects. Both nature-based solution sites that we start with show significant differences in the design of the nature-based solution itself, as they have different agricultural practices, crop rotations, and forms of biomass use. Let me start with the core concept of the modeling approach. The model is based on two central concepts: crop rotation and green manure. These serve as the lowest common denominator of the different case studies in the trans4num project. And the model takes a modular two-dimensional approach divided into 6 functional modules, switching between coarse-grained and fine-grained structure. The functional modules are first agent population, which represents a sample of the case study region; decision behavior, which models the behavior in terms of adoption of innovation, social networking or social relationships, and social learning of the agents that are involved, such as farmers and processors. The social ecological system, which uses a square grid to project environment and neighborhood. Scenario analysis, which simulates baseline and intervention scenarios. A model validation, which compares model results with empirical data and stakeholder feedback. And this 6th functional module will be code transferability, which ensures that the model code is reusable and extensible. The model granularity is initially coarse-grained and can be extended with optional finer-grained submodules that can be activated or deactivated as necessary. Another key element is also the concept of how the decision process is being modeled. We used another agent-based modeling approach from the model repository 𝐖𝐢𝐧𝐧 as a starting point for this. The process starts with the creation of the agent population, and this allows this is followed by the initialization process where we parameterize our model. And then subsequently, the diffusion of the innovative nature-based solutions is modeled. The farmer's decision-making is based mainly on factors such as profitability, social influence, and the willingness to adapt the nature-based solution. And the model then calculates the adoption rate, the impact on farm income, and if desired, other indicators like environmental indicators. But we not only have similarities in our model specification, or in comparison between the different case study sites, we also have a lot of differences and challenges that needs to be addressed in further work on model specification. The main differences between Denmark and China are first regarding age and population, second, different formats of spatial data, third, the number of traditional crop rotation. So we have in Denmark more than 400 different 3-year crop rotations, whereas in Inner Mongolia there are only 2 traditional crop rotations. In Denmark, the exchange of biomass is carried out via biorefinery, whereas in China it is done via animal husbandry. And another very important point is behavioral differences of farmers. These are there are site-specific factors that needs to be addressed. So to close up, or in conclusion, we have set ourselves 3 main objectives regarding model specification. First, understanding the diffusion of nature-based solutions. Second, transferability. The model should be flexibly applicable to different sites. And third, simplicity of design. That means the model should be as simple as possible, but as detailed as necessary in order to ensure a balance between model complexity and traceability. The developed model specification will be used to build a model that helps us to analyze policy interventions to promote the diffusion of nature-based solutions. Through close collaboration with stakeholders, the model will be gradually refined and adapted for the case studies in Denmark and China initially, and for the other stakeholders later. And this brings me to the end. Thank you very much for your attention. And I also would like to say thank you to my co-mentor, Yuquan Chen from the China Agricultural University. It was a very, very fruitful collaboration. Thank you very much.
Thank you very much, Anke, for your presentation and for your results. So our jury, please, 1 question to Anke. Martin?
Yeah, thanks a lot really for this impressive work presented by your contribution. I was wondering, based on the overall outcomes of the pilot and project itself, what do you think? What's your overall evaluation of comparison between EU and China nature-based innovation? What do you think? Where the situation is better, or it's really difficult to, let's say, judge in a nutshell?
What do you mean with a comparison? What is better? What do you mean by it is better? To implement it in the model, or just to about the actually nature-based solution that is proposed?
I was meant the nature-based solution, the B option.
Oh, this is this is difficult because these are so different contexts. You don't, I mean, these are different continents. The Asian population is completely different. All these natural or structural framework is completely different. And that's, I wouldn't compare the nature-based solution itself. That makes it also difficult to put it in one model, in just
Sure.
one core
I
model.
didn't
But there are
meant the question.
similarities, yeah.
I didn't mean the question towards the competition, more towards the direction, whether you spotted some aspects which, for example, Europe shall learn from the China and vice versa.
Yeah, we could use, for example, there are similarities, for example, if we want, from a technical point of view, for example, how to implement the behavior. There are different theories behind it. And there are differences, but also similarities, and we could learn from each other, I would say, for the behavior and the decision-making process. This is in terms of practices within a nature-based solution.
Interesting.
case.
Okay, thanks a lot.
Okay, thank you very much. So I think it's over with the presentations. I would like to thank you to all the teams for your excellent presentations and for sharing your solutions with us today. I'm very excited to see who from you will receive the award of the top of the 3 places. The winners of the hackathon will not only receive certificates recognizing their achievements, but also gift cards valued at 150 and 25 euro to the online shop of the project coordinator, University of Hohenheim. Thank you very much, Foro and University of Hohenheim, for this gift. It's just a small token of appreciation for the incredible effort and innovation you've demonstrated throughout the hackathon. So now it's finally time for our jury to deliberate and make their final decision. So jury members, please head over to the breakout room. So I would like to give floor to my colleague Tomáš Mildorf, who's actually the chairman of the Plan for All Association, who will announce the 3rd, 2nd, and 1st place of our trans4num Inspire Hackathon 2024.
Okay, we actually agreed that Martin will be the one who will announce the winners, the 3 first ones.
Okay. Thanks a lot, Tomáš and Marketka, for the room. Really, I have to say that you didn't make us easy period evaluating all the contributions. We have to admit that all 7 challenges provided the content which is highly valuable, and we have to admit that making the final decisions, which we are just about to announce, was a really tough period. But let's go to the results. Based on that, we came to the conclusion, and we have to say that, of course, we made subjective perceptions. I think it was very nice to see that we were able to come to common agreement that the 3rd, let's say, best challenge we've seen today is challenge number 1, development of spectacular experimental and demonstration tools and content to establish and spread the use of natural-based solution. So congratulations to the challenge number 1. Yes,
congratulations. So maybe, if I may, Zoltán, would you like to say something?
Just a short thank you.
Yeah, really. Thanks also from our side. And if we continue for the 2nd best challenge and presentation made today, I think this goes to the challenge number 5, AI-enhanced geospatial analysis for rural development challenge. So really congratulations to the Karel and his team.
Okay, thank you, Jerry, for this, and I would like thanks to all people, to all team who work on this, and I would like to wish that also other people will join us, and we will continue to develop something in the future, real useful and commercial.
Perfect. Many thanks. And we are there. So based on what we've seen today, the best presentation and the challenge which seems to be winner of this hackathon goes to the challenge number 8, fundamentally different case studies of nature-based solutions. How can they be integrated to a common agreed agent-based modeling? And with that, congratulations to this challenge and the work you've done, because it's significant, visible that there is a lot of results based on your work.
I would like to say thank you so much for this decision. I'm on behalf of the whole challenge number 8 team, I would like to say thank you, and we are very grateful and also excited about this. It was a pleasure to be part of this hackathon, and so thank you very much also for the jury and for the organizers. Thank you.
Many thanks. And the final word from my side, I would really like to thank all the other teams and challenges, because despite of the fact that you are not among those 3 best, I think you deserve huge acknowledgement for the work you've done so far. I think the information that your results will be shared publicly will help to your efforts towards the future. And I can tell that as these kind of results are visible, sooner or later, whatever direction we want to achieve, we keep fingers crossed for your efforts. Thanks a lot once again.
Okay, thank you very much. Thank you, Martin. Thank you, the whole jury. I would like to again congratulate our winners. The certificates and the gift cards will be handed to you in following days. Thank you again, our jury, for their commitment, and thank you most to all of you, the hackathon participants, for your cooperation and dedication. I would like to invite you to the next round of hackathon we are organizing within the trans4num project. It will be in 2026. So we will definitely keep in touch. And yeah, see you soon, see you later. Thank you again, and bye-bye.